So what I'm going to talk about tonight is a little bit about how we do research and innovation around data and machine learning. And this is a topic I've been interested in for a very long time, and I suspect the people in this room are also very interested in this idea. We happen to be at a time where the capabilities we have for working with data have changed dramatically, and we see this reflected in the hype in the news. We see people who legitimately think that general artificial intelligence is coming next month. You know, there's a lot of nonsense out there, but I do think that there's also a lot of truth and validity. We went through sort of the big data phase, which was largely around infrastructure and building systems that helped us collect the data into one place. And once we did that, we could suddenly count things. We started saying, okay, now we've got data, what do we do with it? And so now we're in the AI machine learning algorithms phase, where we say, okay, we have this data, how do we use it to enable new capabilities? And so what I was talking about back here all those years ago with social media data, I was trying to figure out, you know, how do you invent the future of a product or a business or an industry through the data and technology resources that we had access to? And that's what we do at Fast Forward Labs, but with a bit of a different perspective. And so we try and help people think about the future of their business, their industry, new product opportunities through the data and that they have, the business they know very well, and then these emerging machine learning and data capabilities. In order to do that, we have to become a bridge. So this is what we do. Our business is really bridging between research and advising, and so we do our own program of applied research into emerging capabilities, and I will spend most of my time on stage talking about that. The other side of what we do is listening to the problems that people want to solve in the real world. So acting as any mentor or advisor, or really just your nerd best friend. And I imagine everyone in this room is somebody's nerd best friend for something. So you're going to know what that means. You're the person that somebody will call for the cocktail recommendation. You're the person who's most likely to be sitting in front of Google, who someone will call for help with something. We're sort of the nerd best friend for machine learning. And we do bridge between 3 different communities. And so most of the folks on my team, several of you are here. Would you mind putting your hands up? We have Mike in the back, and Aditya up here, and Andre over there, and I saw Catherine as well. She's hiding somewhere. So we tend to come from academic backgrounds, or be what I like to call reformed academics, or people who like to read papers and like to do research, but also like to build things. We work with a lot of folks in enterprise, and we work with a lot of folks in startup. And when you think about where the innovation in machine learning happens, you can make a plausible case for each of these constituencies. The bottom 2 are taken for granted. So we all know that tons of this innovation comes from the research community. A lot of it is happening in startups. But there are challenges in the research community, in that they're not necessarily working on systems that can scale, that can be deployed, that are addressing real market challenges. There are challenges for startups because you don't have data. You might understand a business problem, but it becomes much more complex to also invent the technology while you're inventing your product, while you're inventing your business, and do it on constrained resources. Unless you have very, very generous venture capitalists like Matt. The last case is a bit harder to make. So people think about enterprise, and they think about folks like this company. Nobody innovates in enterprise, but there are actually opportunities there that I think go undermentioned, and those opportunities consist of the fact that folks in enterprise have a business they know very well, and they've known for a long time. Some of the companies we talk to have existed for well over 100 years. They even have data from well over 100 years. And that's the second thing. They have that data. They've been collecting it usually as a side effect of some other business process. It's there. Thanks to folks like Segment, they're getting it all in one place, and they want to do something cool with it. So that's, I think enterprise doesn't get enough credit for the opportunities that are there. That said, there's sort of a gap between what you can buy in the market, which has been the traditional attitude from the enterprise perspective around data innovation, and what you can build. And I typically think of this as sort of the machine learning or AI product gap. And I think this, if you think about it, it sort of makes sense, because when a vendor or a startup is going to build a product that solves your problem, they must solve a generic formulation of the problem. They have to solve everybody's version of your same problem. When you want to solve your problem, you just need to solve your problem on your data for your one application. And machine learning is still hard enough that there is a big difference in the ability to execute on solving the one problem and solving the generic version of that problem. And this means that it's really hard to innovate in the ways that these folks have traditionally done so, which is buying startups and buying products from other companies. It means they have to do it inside, and that's a challenge. So we have a process where we think about what is the most interesting machine learning topic that is emerging today. And this is actually a great day to be talking about this on stage, because we were in our office doing this just this afternoon, and on my phone I have some pictures I can show you if you're interested in the full list. But this is not just sort of think about what is cool, but this is a way to somewhat rigorously identify what these next changes will be and to find them before they become commonplace. What we do at Fast Forward is try and identify things that will be impactful in 6 months to 2 years. So highly applied, things you can actually build into real products today, but also things that are not already overhyped and understood. And it's a really fun place to be. So the first step is to drink a lot of coffee, read a lot of sci-fi, watch TV, go look at art, try and make those creative energies come out and put as many bad ideas as possible down. The second thing is to evaluate each of those bad ideas on a few different criteria. And so that means looking for where there may have been a research breakthrough. And when I say a research breakthrough, everyone pictures the eureka moment where you throw the paper up in the air and shout, I figured it out. Or maybe you're in the shower. I don't know what everyone's individual research fantasy may look like. But it most often is something where there's been research in one domain that is applicable to another domain. So it's not necessarily something entirely new, but rather somebody discovering something that may have existed for a while, but realizing that it's applicable now, given the other things in place, to a problem. Second is a change in the economics that constrain the application of the technique. And I'll show you a few things from the internet. So you can model sort of cost of anything we work with. So CPUs, GPUs, memory, SSDs, hard drives. There's a source for this one, and you see a line that looks roughly like that, more or less. And then this thing I found on Twitter, so I don't know who the original credit goes to, but it's really, this will make you feel old if you actually have been around using technology since 2005, because the one on the left is 128 megabytes. The one on the right is 128 gigabytes, right? Same form factor, probably the same price. This stuff changes dramatically over time. And so when we first got excited about deep learning a few years ago, we wanted to do some stuff and realized we could not afford the compute power necessary to do what we wanted to do. Certainly not at a small technology company. These days, you can afford it. And I expect in a year or two, it'll be trivial to afford it. So we'll have kids doing it on their allowance money versus adults with jobs versus adults with really good jobs. The third thing we look for is that capability becoming commoditized. And that means that people are building things that you can build on top of. I know Ramy was up here earlier talking a bit about his work with Hadoop. I think Hadoop is the classic example of this, because before Hadoop, you could build that kind of infrastructure, but you had to have a team of engineers and infrastructure people to make that work. You would have to build it yourself, so 10 people, maybe. Once Hadoop emerged, you needed a couple people, because it was, if anyone remembers using Hadoop in the late 2000s, not a very lovable open source project. It required a lot of care and tuning and nurturing. Today, you can spin up some cluster on your mobile phone without thinking about it at all. And he talked a bit about the process of building that technology. But that's the kind of commoditization that means that this is now accessible. And we're seeing this in machine learning, primarily in the open source world, in an ongoing basis, almost something new every day. The fourth thing we look for is whether new data is available that makes the problem accessible. And that might mean public data, it might mean data we can partner or borrow. It might mean data that a client has that makes their particular version of a problem accessible. I include the Wikipedia page for data science here for two reasons. The first is that the Wikipedia page for data science is really the dirty secret of tons of data science products. Where it is publicly available, you're allowed to use the data, the license is there. And so if you go back far enough, in pretty much any sort of open API in machine learning, you can find Wikipedia in there somewhere. And it leads to all sorts of weird side effects, like the language coverage of a lot of these tools matches what's in Wikipedia. Entity coverage is the same. The second reason I chose this is because for a long time, the data science page on Wikipedia cited the creation of the data science page on Wikipedia as a major milestone in the emergence of data science, which is the most Wikipedia thing I have ever seen, but does really make the point quite nicely. So if you go through these four things, four criteria, here are a few of the different things that we're really excited about. And so that's what I want to end my presentation with, and hopefully end this long evening. And also thank you all for staying awake so far. And Matt, here is your cat. It's animated. Giphy is the best. Yeah. So one thing we've been excited about for a couple of years is natural language generation. And so this is a technology for taking structured data and generating narrative. Again, when we explore one of these things, we do one every 4 to 6 months, and we do a deep dive into, reading the literature, talking to people, building things with it, writing down on a conceptual level, what is this thing and how does it work? On a mathematical level and engineering level, what is it? How does it work? What do you need to know to build something with it? Where is it going in the near future, 1 to 5 years? In our current project, we actually hired someone to write a science fiction story about the technology, which I think is a pretty exciting way to sort of explore where things may go. We look at the ethical implications of building products with any given algorithm, which also has a lot of relevance for folks working in highly regulated industries, sort of how can this stuff go awry? And do a complete map of sort of the commercial landscape of what's available if you want to make the decision on whether to build something or buy something. How do you think through that whole process? This is one of the things we're really excited about. And most people who have heard about it sort of see it in this context. So reporters hate natural language generation, and they hate it because they think it's going to replace their jobs. And this is true at the AP. They're working with a company called Automated Insights to write a bunch of finance stories. They actually have someone called Automation Editor whose job it is to manage these algorithmic systems generating content, which I think is a pretty cool job. So we built a working prototype here that allows you to take structured data like a New York City apartment description and generate potential advertisements that describe that apartment. And so this is trained off of 60,000 New York City apartment listings. We learned a bunch of interesting things in analyzing that data. So a few things that won't surprise anyone if you've actually gone through the apartment hunt in New York, one of which is that if it says cozy, it is 400 square feet smaller than the average for that zip code. It gets better because if it says it is large or spacious or grand or any synonym of that, it is at the average or slightly below, showing that if a real estate agent ever writes about the size of a property, it is small. So you should keep that in mind. And that's the kind of thing that emerges from taking the unstructured data paired with the structured data and building the model that can then generate new results. And you can do things with this system like have it generate a listing for like a 1-bedroom, 9-bathroom apartment, which I don't believe exists. It certainly didn't exist in the training data, and sort of see what'll come out. It gets a little weird, but it's fun. The real impact here is not in replacing reporters, but in helping people understand complex data. And so what I'm trying to illustrate here is that some people are happy looking at this, like, maybe many of you in this room. But believe me, not everyone is. Some people like graphs. This is an interpretation, not of this data, but of some data. More people like sentences. They like language. They like to be able to quickly draw the insight out of the numerical content without having to expend the emotional energy to go through this process on their own. And so when we think about the impact of this technology, it's easy to say, oh, it's going to replace a couple of reporters. Yes, that's step 0. But step 1 is going to actually change the way that many people interact with complex numerical data across a variety of products. And that's really exciting. So another thing we're particularly excited about, but I know everybody is using deep learning for analyzing rich media. For this one I'm sharing more to tell you a story about something that went wrong. And because we do, research and then advising on products and building a couple of products, we're allowed to make mistakes in public. I know many folks who are working on products don't publicly share their mistakes, but if you get them together at a conference after hours and you ask, like, where did your machine learning systems go awry, you get the best stories. For this thing, we built a system that you can auth into with Instagram, and it says, here's a visualization of what you like to take pictures of. Here is Tourism Ireland. It does a pretty good job. There are some pretty clever things in how it goes from many different tags with probabilities to sort of a couple of reasonable labels. When I put my Instagram photos in here, it told me I like to take pictures of prisons and correctional institutions. And so you're laughing because you can tell from looking at me, I've probably never been to one. I haven't. I've never been to a prison as far as I know. And I was pretty confused. I'm like, why is this? Well, it turns out I'm from New York. I spent a lot of time in the New York City subway system, which I take pictures in the subway system. And there was no training data in the ImageNet data set of the New York City subway system. The closest thing in the system was prisons. And so this is a funny story, but it really does make you think about where we deploy these sorts of algorithms and what can go wrong. And here's another view into our tool here. This is really powerful because you can analyze and quantify rich media data. And again, I used to work at Bitly, which is a social media company, and around 12% of the links we saw on a daily basis were primarily media objects, and we had no insight into them. I'm almost done. Last spring, we looked at Summarization, which is LDA neural networks for extracting sentences from text. You can take an article. It will highlight the article to show you what you need to read. The idea being if you read only the highlighted sentences, you will get the entire set of content in the full article. This is a new capability. So we look at some things like this, like the image analysis with neural networks, because they are completely new. 5 years ago, we could not do this. Now we can do it. Here's another view of the LDA approach where you can throw in all of the in this case, product reviews from Amazon, and have it say, of these 5,000 reviews, here are the clusters and here are the sentences that are typical of what people in those clusters talk about. We did this on the pet product category because those people are insane, and the results are really, really funny. Yeah. So this is moving beyond just counting words to making language computable in a few interesting ways. And one that we have not released and we've never talked about publicly, so you're getting a preview. We just wrapped this up, is on probabilistic programming. So the pitch here, a couple months ago would have been, you too can be Nate Silver in 5 lines of code. Nobody wants to be Nate Silver anymore, so we need a better story. But the idea is that it's making Bayesian inference very accessible to a much wider audience. And again, this is one where it's not a completely new capability, but it is newly accessible. And much, much easier and cheaper, and that makes it very interesting. And so we have a couple of prototypes that will come out soon where you can play with making decisions, where you get a return profile and a very nice confidence interval on those things for making risky decisions. And we have another real estate prototype that will cause you to cry if you ever want to buy something in New York, but sort of predicting what prices may look like over time, where you can buy a property over time. And real estate is a fantastic inference problem because the only way to know the value of a property is to sell it, but obviously we don't sell every property every day. And so it's a lot of fun. And this is interesting because a lot of the stuff we do and that you'll see people talking about at events like this requires very large, very clean data sets and takes the sort of human creativity piece of it out of it as much as possible. So in deep learning, you're not doing feature engineering anymore. Nobody cares about what you know about the domain. Here, you're able to combine your domain knowledge and your prior assumptions with, sort of smaller data sets to actually learn something useful about the world, which is sort of a different approach and different mindset. And with that, I'll conclude. So cute robots are also as good as cute cats. I'm saying these are just a few of the things we're really excited about. I want to hear what you're really excited about, and so I'll be hanging around for a bit, but also grab any one of my colleagues and tell them the thing that you think is going to be impactful in the next year or two, because we would love to hear it. And with that, thank you very much.
Join us just for a couple of minutes, and then we'll wrap.
Yeah, I saw that flashing red thing in the back.
Yes, it's a little bit of a hint, the big red thing. So thanks very much for, especially for sharing all the things that you guys are working on and are excited about. Is there anything that you guys looked at and felt, okay, this is just not ready for prime time? It sounds like it is ready for prime time, but it's really not.
So I have a few strong opinions on that my colleagues may not agree with, so I'll preface it by that. I think there are a couple of things that everyone thinks are solved problems that are absolutely not, and so something like sentiment analysis is something where we sort of take for granted that you can just plug into an API and get a number back, but this is also a problem where if we took everyone in this room and had them rate the sentiment of a document, we would not agree. So the ground truth is lacking, and so the tools are in many cases lacking. Now, some of the newer approaches may make that an interesting problem, and we may finally be able to get to a reasonable solution. But that's one where I think the common wisdom is sort of missing the point.
Right.
I have more, but we can go on.
Yeah, maybe time for one. I thought there was one here. Otherwise, I'd love to hear the other one that you have in mind.
There must be one question, even about the cat or something.
It's over there.
These are all interesting. The very last example you showed on real estate, do you use data from like Yelp or publicly available data to make these predictions?
So that one, it's publicly available data. I'm not entirely sure what data is in that specific version of the model, though Mike in the back can probably tell you that. It's what? So it's just the New York City data, finally. Thank you.
Great. One last question here.
Hi, thank you very much. It was very interesting. I have a question about how you pull information out of the academic space, because publications is the one thing, but especially in computer science, the context of information is really in the researcher's head. And so there'll be like 100 conferences, but only 2 will really be meaningful. Or there'll be a journal, but only one of the publications in there will be meaningful, and it's all the context is in the brain of the academics. How do you guys, have you found a way to approach a new area of research and extract what is the value and where is it and which venues or which publications?
So that's a great question, and you're right, so it's messy. And so I really believe if you want to know what someone did a year ago, you read their publication, and if you want to know what they're doing now, you watch them give a talk like this, and if you want to know the sort of wacky ideas they're thinking about, you have to give them a beer or some whiskey and have an informal, off-the-record discussion. And so we do not have a lot of rigor around that, but do maintain a lot of relationships with people and spend a lot of time to really and this is why I asked this question in this room. So trying to ask people, what are you excited about? Why are you thinking about it? What are the problems you're working on right now? And for a computer scientist like me, that can be a bit of a struggle because you have to actually talk to people. But if you do that over time, it gets easier and you start to learn useful things and see trends.
All right. Thank you so much, Hilary.
Thank you, Matt.
We appreciate it.